In today's video, we'll be looking at fiber optics, which forms one of the compulsory topics that you need to know for your physics exam. Typically, for WAEC exam, this topic comes from in question number 1 to question number 7. Okay, this is one of the topic you must know. And in today's lesson, I'm going to be showing you all the possible questions WAEC can set for you in your physics examination paper 2. Okay, so now many students overread this topic. Some will even be reading all the calculations they are coming across. But WAEC don't test calculation around fiber optics. Okay, so in this note has been prepared specifically for preparation for exam. Okay, so if you know all the questions we are going to, you know answers to all the questions we are going to be discussing in this video, then you are good. You are going to be very okay for the exam. There is no question they will ask you that is not going to be discussed in this video. Okay, so this will form one of many um, series of videos for the preparation of your physics exam. Okay, for your physics exam, it's divided for WAEC. It is divided into two sections: section A and section B. Section A contains 7 questions where you are going to be asked to answer 5, and there are some specific topics that comes from that section A. Okay, so there are some specific 10 topics that WAEC is to bring out questions um, for that section A. You have dimension and dimensional analysis. You have your elasticity. You have your projectile motion. You have satellites. You have magnetic materials, um, fiber optics, and some other topics. So fiber optics is one of the topics you must know. Okay, so that you can quickly get your 3 marks and move away. Now let's get right to that. Fiber optics. Now, what is fiber optics? So fiber optics is the technology of transmitting light signals through very thin strands of glass or plastic fibers over long distance. You must have seen sometimes, maybe in your area, you see some engineers trying to bury a certain cable underground. Okay, that cable they are trying to bury underground contains fiber optics for carrying of what of signals from one place to another. So that technology is what we call fiber optics, while the material itself is called optical fiber. So an optical fiber is a thin, flexible strand of glass or plastic that carries light signals from one point to another. So you must know this definition. Now they can also ask you what are the main parts of optical fiber. There are 3 main parts of optical fiber. We have the core. Okay, that core is the one that carry the light signals, while we have a cladding. Cladding is always surrounding the core. Okay, let me show you a picture of a typical optical fiber. So this is a picture of a typical optical fiber. Okay, you can see that the the innermost component is the glass core. Then we have a glass cladding. Okay, then we have a buffer. This buffer is a coating. Okay, then usually sometimes we have another part that is not really part of the optical fiber itself, just a protective layer, which we call another extra protective layer, which is the outer jacket. Okay, so the core part is the one that carries the light. The cladding surrounds the core and reflects light back into it. Then we have the protective coating that prevents the fiber from damage. And sometimes we would have another extra layer, but that extra layer is not part of the um, optical fiber. It's just another extra layer to prevent it from damage. Okay, so what are the materials for making optical fiber? Of course, you see that we have already mentioned some of the materials here. We have mentioned glass or plastic. They are also materials used for making optical fiber. So they ask you to mention materials of optical fiber. These are the accepted answers from WAEC and NECO marking scheme. It is glass, polycarbonate, Teflon sheet, silica, quartz, silicon, and sapphire. So just know any of these. Okay, you can be tested. So now, actually, the term refractive index is a concept in light, not directly on the optical fiber. For the fact that optical fiber is an application of um, light, so that's why this question is coming in. And what's refractive index? So it's a measure of how much light slows down when it moves through a medium. So how much light slows down when it travels through a medium. That's what we call refractive index. For example, light traveling from air to glass, the refractive index of light traveling to glass is 1.5. We have some other glass material that is 1.6. Also, light traveling through air into water has a refractive index of around 1.3333. So this is how much light slows down, okay, or how much light bends towards the normal when it moves from a less dense medium to denser medium. Now, this is one of the most common. The next question now, which is under the second principle, the second point, which is principle of transmission of light. So this is a much more common question, which is the basic principle behind fiber optics. Okay, and the answer is fiber optics operates or works based on the concept of total internal reflection. So it works based on the concept of total internal. So take note of this. So in the complete reflection of light back into a denser medium, that is what internal reflection is. It's the complete reflection of light back into the denser medium when it hits the boundary at which angle greater than the critical angle. Now the condition, we're going to discuss that in a minute. For us to have total internal reflection um, occurs, there must be two conditions for it to occur. And two conditions has been mentioned in this definition. The condition are light must be traveling from denser medium to a less dense medium, and the angle of incidence must be greater than the critical angle. So in case you're asked, mention two conditions necessary for total internal reflection to occur. They are what? Light must be traveling from the denser medium to less dense medium, and the angle of incidence must be greater than what? Critical angle. Then what is critical angle? So say critical angle is the minimum angle of incidence at which total internal reflection may occur. Okay, so take note of that definition. For us to have total internal reflection, the incidence, eh, the angle of incidence must be at least equal to what? Critical angle. So how does light travels in an optical fiber? Okay, very easy. You see the diagram I showed you the other time. Okay, so in this diagram, light enters the fiber, that is the optical fiber, the core, and keeps reflecting off the wall of the core due to total internal reflection. So allowing it to travel through long distance. So um, as the light that is inside the core, as it keeps reflecting internally in the core, uh, bouncing off the cladding, it allows that light to be able to travel through a long distance. So now the question is, why is cladding important in optical fiber? Cladding has a low refractive index than the core. Okay, so meaning the core is much more denser than the cladding. Hence, it's like light wants to travel from the core to the what? To the cladding. So as it wants to travel through the from the core to the cladding at an angle that is greater than the critical angle, it's continuing to bounce off. Okay, which helps keep light trapped. So it helps the light or signal to be trapped that within that core, so that the light is not lost. So it's going to be able to because of the concept of total internal reflection, the light will be able to travel through a very long distance. Now, this is the formula for calculating critical angle when the refractive index is low. This is the relationship between um, the critical angle and the refractive index. Okay, so say sine c is equals to what? 1 over n, where c is the critical angle. So for you to calculate to obtain for you to obtain C, all you need to do is substitute the value of n, then take the sine inverse of both sides. For example, we have um, we have sine sine C equals to 1 over 1.5. So 1 over 1.5 is the same thing as 2 over 3. So if you you evaluate 2 over 3. After evaluating 2 over 3, you should get 0.6667. Then you take sine inverse of 0.667. That will give you the value of what? The value of the critical angle. So what happens if angle of incidence is less than angle of the critical angle? Of course, we are not going to have what we want. So the light will refract out of the fiber instead of being reflected. There will be refraction rather than a reflection. Okay, and you remember your Snell's law. N is equals to sine I over what? Over sine R. So you can, from here, if you know the refractive index of the material, you can calculate the angle of refraction based on the angle of incidence that you have. Okay, so what are the types of um, mention types of um, the fibers that we can have, fiber optics material that we can have. So we can have single core, single mode fiber, and multi-mode fiber. So take note of that. Now, since this is exam focused, we'll not be over dwelling on most of those concepts, so that the video will not be too long and it will serve as a material for you to quickly revise for your exam. What's the mode? What's the difference between single mode and multi-mode fiber? Good. A single mode fiber, okay, carries light in just one path, long distance communication. Especially it is used majorly for long distance communication. While multi-mode carries light in many paths, okay, and majorly it's used for what? Short distance communication. So that's one major difference between them. Two differences have been mentioned, and one difference is one is it carries light in one path, and the other one carries light in in many paths. So when we need to carry signals through long distance, use single mode. When we use to carry light through short distance, you can use multi mode. What are the advantages of fiber optics? Now, say state two advantages of fiber optics over copper wires. Now these are two. These are four. One, faster data transmission. Okay, it can transmit data um, faster. Okay, and than copper materials, and also less of the signals is lost because of the concept of total internal reflection between the core and the cladding. Okay, so less of signal is lost. Immune to electromagnetic interference. Yes, another that's uh, another advantage of fiber optics. They are designed to be immune to what? Electromagnetic interference, and they are much more secure. They are much more secure. Now, application of fiber optics. That's the next concept. The next few questions we'll be looking at is on applications. One, state use of fiber. What is fiber optics used for? Of course, majorly for telecommunication. One, internet transmission. For you to be able to get signals wherever you have. Okay, fiber optics are used to achieve that. Okay, cable television. Okay, also televisions that uses cables, they also work on these principles, and all your telephone systems. Okay, within a particular office you might see there might be cables that telephones are wired based on using fiber optics, so that you can be able to communicate in a particular area. Okay, now what is a LAN and how is fiber optics used in LAN? Yes, LAN stands for local area network. It's a network that connects computers within a small area. Okay, fiber optics is used to transmit data at very high speed within the network. So sometimes you see communication within a particular office, okay, which is a small area, but within that, they don't necessarily need to use the same internet they use to communicate with somebody in London. But with the concept, uh, with the application of fiber optics, within that small area, they can communicate if well the well-wired fiber optics. How is fiber optics used in medicine? Well, it is that's a lot of applications in medicine. One of which is in the concept of endoscopy. Endoscopy. Endo means when we say the word endo, what endo means internal and scope means look and watch or to view. So used in endoscopy in various internal organs and used in laser surgery. So yes, for example, there are some lights that are specially used by surgeons when they during operation to be able to view inside of a patient. Okay, they don't use the ordinary light because of generation of heat, okay, which can damage tissues. So um, fiber optics are used to because they are in the intensity can be controlled and they are not as hot as the normal light. So they are good for surgery and they are used for viewing internal organs and also for um, laser surgery. So what's endoscope? A medical instrument that uses fiber optics to view internal, as I've explained before, view inside of the body. So how are the fiber optics used in sensing device? They are used in sensors to detect changes in temperature, pressure, and strain. So, so how are fiber optics used in carrying laser beams? Okay, they transmit laser light efficiently for application like surgery and industrial cutting. Yes, one of the applications of laser is that generally they can be used for some special organs for use for surgery for special organs in the body, and they also use for um, industrial cuttings. So fiber optics are used together with these laser beams in order to achieve this. Now, it also has its own disadvantage, and some of the disadvantage is this: they are very expensive, okay, and they are fragile because of the fact that their internal core is made with glass. Yes, they are made with glass or materials that are not so strong, so they can easily break. They break easily, and they usually require skilled technicians. And for you to require skilled technicians, it's usually very expensive to install. Also, another question is explain briefly how light is transmitted through an optical fiber. This is actually from the past question. The list light enters the optical fiber and undergoes repeated total internal reflection at the boundary between the core and the cladding, as I have explained earlier, allowing it to travel um, through the fiber with minimal loss and can also travel through a long distance. The two applications of fiber optics, yes, application is used in communication, we have mentioned that, and it's also used in medicine, endoscopy or for surgery. Okay, so these are some of the things you must know. Okay, just a quick summary of what we have discussed so far. Fiber optics transmit light signals, works on total internal concept of total internal reflection, and the angle of incidence must be greater than the critical angle. And these are some of the uses of using of fiber optics using communication, using medicine, using sensors, uh, and also using laser transmission. So with this, you are rest assured that there's no question that can be tested on fiber optics that you will not be able to what to answer. Focus on understanding the concept alongside also um, memorize the definitions that you think you have not grabbed. Make sure you memorize them so that when it comes, pick your answer and smile and be happy. So this will form one of the series of videos that I'm going to make on this concept. Okay, it's going to form a series of videos that I'm going to make on this particular for your exam specifically, exam focused explanations and questions. Okay, so we're going to do for all different topics. Okay, maybe possibly we start with um those ones that are from the compulsory part. Okay, so try as much as possible to make sure you have subscribed and share the video with your colleagues and leave a like so that the channel will also reach a lot of audience. So thank you. See you in the next